Okay, guys, so we talked about parallel lines and how the slopes determine our parallel lines. So now we're going to talk about perpendicular lines. Okay, first thing, what the heck are perpendicular lines? Perpendicular lines intersect to make what we call 90-degree angles. Okay, a little geometry thrown in there, not a big deal, right? 90-degree angles are also known as right angles. You'll dive more into that in geometry, but that's just the basics of 90-degree angles. They are right angles. A lot of people think that the easiest way to determine it is that they look like an X. Sometimes they look like a T. Okay. All right. Now, we can't just look at the picture and say these are perpendicular because they make an X or because they make a T. If I turn the graph sideways, it looks like they make a T. We can't assume that. We have to prove it. Okay. And the way we prove it is through slope. All right. Perpendicular lines are different than parallel because obviously these lines cross. These slopes are what we call opposite reciprocals. Okay. Now, what I mean by opposite, when I say opposite, we're talking positive, negative. And when I say reciprocal, we're talking flip. Right. So we're talking flipping the fraction. So they got to be both. They can't just be one or the other. They got to be both. So if you see off to the left here, I have a little prep work done there just to save a little bit of time. The blue line I called L1. I'm going to find that slope using the graph. Okay, so if I was to go from this point to this point on line number one, L1, that would be down 1, 2, 3. So I'm going down 3. So your rise is actually going to be -3. And then I'm running 1, 2, 3, 4, 5, 6. So your run is 6. -3/6, which is -1/2. So the slope of L1 is -1/2. I'm just going to highlight it so I can come back and refer to it. Okay. Then I look at my red line, which I decided to call L2. Okay. And I'm going to do the formula for this one just to practice the formula, just to get some extra reinforcement of the slope formula. So you got these points here. All right. I don't know why it's not on the pen. All right. Medium point. I want red. There we go. Okay. So this would be your x1, y1, x2, y2. So y2 minus y1 would be 4 minus 2 on top of x2 minus x1, 1 minus 4. 4 minus 2 is 2. 1 minus 4 is, oh, wait, I made a mistake. -4 minus 2. Sorry about that. Okay, so -4 minus 2 is -6 on top of 1 minus 4, which is -3. Negative divided by a negative makes a positive, so my answer there is 2. So your slope there is 2. Now, are they opposite reciprocals? The answer is yes. Okay, first off, they are opposites. The top one there is a positive. The bottom one is a negative. So anytime you have a positive negative combination, that's good. And 1/2 is the flipped over version of 2, which would be 2/1. Okay, so you have one slope being -1/2. You have the other slope being positive 2/1. They're opposites. Okay, positive negative combination, and they are the flipped version of each other. Now, if you want a trick to help you out, if you multiply these two numbers together, the 2's are going to cancel out. The 1's would also cancel out. Okay, when everything cancels, that gives you a 1. Okay, and then obviously that negative sign didn't go anywhere. It's -1. Opposite reciprocals will always multiply to make -1. So that's kind of a little trick to help you out there. Opposite reciprocals always multiply to make -1. So we can say that L1, the symbol for perpendicular is an upside down T. L1 is perpendicular to L2 because their slopes are opposite reciprocals.